t minus omega square t I. Quite a long. No, I think I can fit it in there.
You can cancel those now.
Yes.
We can cancel those now.
Okay. Looking at this term, and this term. They all have the same e to the I lambda 1t, right? So what I want to do is I want to group all these terms and then factor out e to the I lambda 1. So I have minus lambda 1 squared plus 2 gamma lambda 1 plus omega squared equals e to the I lambda 1 t plus lambda 2 squared minus 2 gamma lambda 2 I I minus omega squared e to the I equal to t. So it gets simplified quite a bit once we do that, right? Now, these have to be equal to 0. Why do they have to be equal to 0?
Because they cancel out. Or
does anyone know? Is e to the I gamma 1t always 0?
No.
No, it's not. These are these are random, right? They can be 0, they might not be 0, but t changes, so they might not necessarily be 0. But this equation states that this thing has to be 0 for all time. For that to be true, these coefficients out front need to be 0. So that means each one of these has to be 0. So we have lambda 1 squared plus 2 gamma lambda 1 I plus omega squared equals 0. Lambda 2 squared minus 2 gamma lambda 2 I plus omega squared equals 0. How do we solve these? Quadratic formula, yes. The most important formula in the world. It actually kind of is. You can't really solve any problems without it. So, okay, so we do that. We have
or lambda.
Notice these
Lambda is a
equations are the
constant.
same, right? These are
This
the
one.
exact same equation. The only difference is one has a
And
2
gamma is
on
the
the little subscript,
variable.
and there's a negative multiplied through here. This one should have a negative, right? This omega should have a negative. So they're just the same equation multiplied. So I'm just going to write this
No, what
gamma
is lambda
here as
for?
a general gamma. It
What's
applies to
lambda
both of
stand
them because
for?
they're the same equation. But keep in mind, there's still 2 equations. So that means there's 2 equations. Each one has to be solved with quadratic formulas. How many solutions are there? Yep, 4 solutions. So when we write out the final solution, you actually need to have 4 gammas written, right? Okay. So we do this.
Yeah.
Minus 2 gamma I plus minus square root 2 gamma I squared minus 4 times 1
I don't know.
minus omega squared
My phone ran out of memory at some
2
point.
times 1.
So I don't know until what it stopped.
If you simplify and do all this, sorry,
What?
I wrote simplify too. If you do this and you simplify, we should get gamma equals lambda I plus minus square root omega squared minus gamma squared.
I'm living considering
So our final
finding a
solution
camera,
becomes
spare
x
camera,
of t
and connecting it to my laptop that
equals
has more
a
memory, and just recording
e
it
to the
there.
I gamma I
It's
plus
actually so much
minus
more
square
worth it to do
root
that.
omega squared minus gamma squared minus e I gamma I plus minus square root omega squared minus gamma squared.
I think robot should take over. I think robot should take over.
Okay? Notice when we multiply this I out here, we get a minus gamma and a minus gamma and a t. We have a minus gamma and a minus gamma t on both these terms. We can factor it out. So we have a e minus gamma t times e I plus minus square root, another square minus grand square root t, minus e to the I, plus minus square, supposed to be minus. Another square minus grand square.
Okay, where's the two T? What's your two T's?
Huh?
Two T's. He took out the T's, but the T's are still there.
No, the T.
Yeah.
No, it's
E to the negative gamma T.
It's a power.
No, sorry.
Yeah.
That's fine.
What is
And
it?
this is not, this is
What?
okay. Alright, so how do we get our sign out of this?
Well, W.
Well, we can choose
Two
these, right?
RT
We can choose
is
these to be positive or
constant,
negative, right? So, if we choose this one to be positive and this one to be
It's
negative,
like cosine.
we should get a sine mode. So it's 2i sine omega squared minus gamma squared t squared,
Will this be on the exam?
right? So this is your oscillating current.
Oh no, I'm about to go to the memory again.
Remember, Ricky, it gets harder from here.
This is called your damping.
Yeah.
You gotta delete another video. Delete one of the.
So this thing oscillates as
Do
this thing dampens,
It's
right?
just not.
So if we just plug in t
I
equals
was
0
trying-
here,
I'm trying. I thought you were trying to figure it out.
this a should start out at 0, right? Because this is 0,
Zero.
this is 0, so this is 1, minus 1. So it starts out at 0,
Here, hold this.
and then it goes up as this line comes down. So this is E gamma T. It hits, comes back, oscillates.